Hello viewers, this tutorial series is going to be very fruitful if you are looking for hands-on training on Docker, Podman-like container-based technologies, and Kubernetes and OpenShift for container orchestration systems. This tutorial will certainly help you for preparation of RedHat Exam 188, Specialist in Containers. I will cover all the topics and aspects of Exam 188 and also include exam tips at the end of the series. So good luck and happy learning to all. Hello everyone, welcome to my channel Tech Tejendra, and let me start the chapter 1 of the specialist in containers. In this tutorial we will see the overview of containers and the Podman, and then we will do some hands-on in the three labs. One is creating containers, containers networking, and the accessing of containers. So first question is, what is container? So a container is an encapsulated process that includes the required runtime dependencies for the program to run. Okay, so you are already aware of your traditional OS, like your Windows operating system, or maybe you might be using the Linux, or you might be the Mac OS, right? So here, like how the application is running in the traditional OS is, one is your hardware, and above of your hardware, then you are having your host operating system like Windows. Maybe it could be the Linux, maybe the Mac OS, maybe the Ubuntu, and then you are having some set of libraries. Like if you wanted to run the Java application, then you might be needed the Java libraries. If you need to run the Python application, you require the Python libraries. Then top of it, you will be having your applications, like suppose this application app A is the Java applications, then Java applications will be required the Java libraries. Like if it is the Python application app B, then it will be requiring the Python libraries, right? So this is the whole about the traditional OS, and you already aware about it. Now, if we talk about the containers, then how containers will run the same applications. Okay, so you will be having your containers, means first you will be having your hardware. Above it, you will be having any of your operating system. It could be any, again, the Windows or Linux, or maybe the Mac OS. Then above it, you will have a container engine. Okay, inside this container engine, containers will be running, and in this container you will encapsulate the libraries, other dependencies, and your application code. Okay, so your application, right? So whatever dependencies, whatever libraries is required to run your application, these everything inside the container. So in that case, the container would be very much portable. You can increase the number of containers if the traffic is increasing for your applications. Okay, so these are the all benefits the container is providing. And in the microservice architecture, right? So once we are developing applications, right? We are transferring applications from monolithic to the microservices. We are breaking down the application into a number of microservices. These containers are the very good environment to run these microservices. So each microservice will run inside a container. Okay, we will understand these containers in more details. I am not going into the theory as of now. You will understand every part of the containers in the more details once we will go ahead, and once we will do the hands-on. Okay, so my main focus is to provide the hands-on via the labs, so that you can understand the containers in a very good way. So let me go ahead. One more thing here is containers provide the virtualization environment, right? Here is the traditional OS you see, and then the container. So container is the virtualized environment. And same way we are having the virtual machines. A lot of cloud services are providing the virtual machines also. Okay. So what is difference between the virtual machines and the containers? So here are the differences. Virtual machines require the hypervisor. Okay. It could be the VMware or the Hyper-V. Instead, containers require the container engine like Docker and the Podman. Okay, and for VM to run, we require the VM management interface, and to container run, we require the some container engine like Docker, Podman, or the orchestration software like Kubernetes and the OpenShift. Okay, and this is the fully virtualized environment, and this is relevant parts only. Size is measured in the gigabytes, right? So virtual machine size is big, and container size is very small. That's why it is the very much portable. And once the container is there, then you can put this container in any kind of environment which is supporting the container, and its size is very minimal, like megabytes only. Portability, generally only same hypervisor, and the container could be run in any OCI compliant instance, right? So it is the very much portable. That's why this is the main advantage of using the containers. That's why it is supporting via the many cloud platform, and many applications which is running in the microservices can use the containers as a runtime. So let me go ahead again, not going into the theory in deep. Let we will start doing the things. Okay, you must be aware if you have learning the container, you must be aware about the Docker. Okay, but if we are talking about the exam 188, Red Hat exam 188, then the Podman is the thing, right? So Podman is same as Docker, and from Red Hat exam perspective, you have to work on the Podman instead of the Docker. And here are some differences between the Podman and Docker, though they both are same. The commands, everything are same. Only things is the Docker command is starting with the Docker keyword, but the Podman command will start with the Podman keyword. That's all. Otherwise, all the commands will be the same for the both. And the basic difference between is that Docker, once we run the Docker, it's first create a Docker daemon thread, and then every command, everything will be executed in the Docker daemon. Okay, instead of it, Podman do not have any daemon thread. Okay, so here this is the advantage of using the Podman, because by using the daemon thread, is the extra overhead on the operating system, and this is the single point of failure also. Okay, that's why Podman is having edge over the Docker, and now Podman is also being widely used in the industry. So good to you can also start using the Podman. Okay, and for the exam of 188, it is the mandatory to use the Podman. Next is how you can get the Podman. Okay, so for these exercise, for these tutorials, and for the preparation of the exam 188, you need the Podman. So you can go to the podman-docstep.io, and you can download the Podman desktop in your machines. Okay, whatever operating system you might be having, either Windows, Mac OS, or the Linux, you can download the Docker desktop. Once you are having the Docker desktop or installed in your machine, then these are the different packages will come with the come with the Podman desktop. One is Podman, and then here is the some other environment also, like the OpenShift local and the developer sandbox. We might be using them in future. Okay, so let me go ahead. Windows PowerShell. Okay, and my Podman is already installed here. And if you are you already have installed the Podman successfully, then if you will run the command podman hyphen v means version, or you can give the command podman hyphen version. Okay, it will return the Podman information, like I am running the Podman version 4.5. Okay, so you can download the Docker Podman desktop, and then you can open the CLI and can run this command. If Podman is successfully installed, you will get the result. Then let me move towards our lab. Okay, so that you can understand the environment. So let me do the first lab, which is the creating the containers. Okay, how we can create the containers using the Podman container engine. Okay, so I will explain command. I will execute the command and also explain you the command. Okay, one by one. So Podman is installed. Okay, and if we will give command Podman images, you can see as of now we do not have any image here. Okay, now let me execute this command, which is the Podman pull, and here is one URL. Okay, and this URL is of the registry URL. Okay, you might be having heard about the Docker Hub. Okay, so Docker Hub is also a registry from where we can pull the images, okay, or container images of our applications, and we can run it. Okay, as of now, and for the exam 188 perspective, we cannot use the Docker Hub. Okay, and this is the registry. Okay, this is the Red Hat registry in which we are having number of images. Okay, so via this command, what we are trying to do is, uh, Podman is the keyword, and then we are pull means we will pull the image from the registry, and registry.access.redhat.com is the registry URL from where we will get the registry, and this is our image name ubi-minimal. Okay, so this UBI is the universal base image of the Red Hat Linux. Okay, so once we will execute this command, it will get the minimal image of the Red Hat universal base image, and then colon, and after this colon we are providing 8.8. It means it is the version, or we can say in the term of container, we can say it is the tag. Okay, so either we can say tag or the version. So this is the version of the image or tag of the image, and once we will execute it, it will download the image in our local machine and in our local engine. Okay, that Podman engine. So let me execute it. So it is trying to connect to the registry.access.redhat.com and trying to getting the image. Now you can see it is started getting the image from the server. Okay, let's wait for a moment till this action completed. This action has been completed. Now let me again see whether we are having the image or not. Podman images will return whatever image are there in our Podman engine. So now you can see this is the image we are having, and this is the tag 8.8 image. This is the image ID. Okay, and the size of the image and the date once this image has been created. Okay, now let me move to the next um command. Okay, and before it, let me execute the podman ps command. Okay, so podman ps command means processes inside the Docker engine. Okay, so if we run it, we see that as of now no processes is running here. Okay, we are having one image, but no process means once we create the process, then this is the running of the image is the process. Okay, so let me clear it, and then let me run this command. Okay, podman run. Okay, so what this run command will do, it will run the image. Okay, so and it will create the process and it will run the image. Okay, this is the run command. So we are going to run this image which is already in our local repo now, and then because it is the universal base image of the Linux. Okay, so what we are doing here, we are running this image in the container, and then we are echoing a line. Like echo means it will, if we are giving instructions to the Linux, that echo this line, hello Red Hat. Okay, so let me run it. So what it will do in the background, it will create a container. Okay, and inside this container it will run the image. Okay, this base ubi minimal image, and then it will pass this instruction to the image, and then this image will print it. Like, okay, so this has been printed here, hello Red Hat. Okay, if we see the Podman PS again, it is returning nothing. But if we will run the Podman PS hyphen a means all. Okay, whatever processes are there, either exited or the stopped, it will return the all. Okay, so here we can see this is the container was there, processes was there, and this status it's executed exited. Okay, so this container has been finished 36 seconds ago. Okay, so let me go ahead, and then let me run the another command of the podman. Okay, and here what we are trying to do is, now again we are running this image here. Okay, the same image we are running, and then while we are running this image, we are setting some environment of the to the container. Okay, once the container will be created from this image, we are setting these environment variable. Okay, so hyphen e is the means with this attribute hyphen e, we are providing the key and value. Okay, so these key and value will be treated as the environment variable, okay, in the container. So hyphen e greet hello, and another environment variable is the name red hat. Okay, and then this is our image, and from this image the container will be created. Once container is there, then we are passing this command to the container to run, which is the print environment. Okay, and these two environment it will print, okay, greet and the name. So let me execute this command. Here you can see it has been printed these two environment variable values, right, the hello and the red hat. And if again we will see the ps-a, we can see now the two containers are here and both containers are in exited status. Okay, now let me execute the another command. And in this command, let me start a HTTPD server, okay, the web server. So I have given this command, and let me tell you the meaning of this command. It will run, okay, what it will do. Okay, we do not have this image in our registry, okay, in our local system. So what it will do, it will connect to the registry.access.redhat.com, and then it will get the image of the httpd 24. Okay, this is the server, web server. So it will get the web server image, then it will run this web server. Then what it will do, it will create the container of this web server. It will run this container in the background. Hyphen, once we are giving the hyphen d attribute, it means it will run as a daemon thread. Okay, means it will run in the in a different thread. Okay, not in this current thread. It means it will run as a background. And hyphen p attribute is related to the port. So what we are doing here, we are assigning our local port, right? I am running this application from my Windows machine. Okay, so my local Windows machine 8080 port will be assigned to the container port 8080. We will talk about this later in the networking section. As of now, we are going to first getting this image from the image registry. Then we will create a container, and then we are doing the port forwarding here, and we'll run this container into the background, and then we will see the result of this container. Okay, so let first execute this command. So what it is trying to do, first it is trying to get the image from the registry. So let's wait for the moment till it get the image connecting to the registry, and will get the image. Okay, so it has get the image from the repository, and now the container is also being run, right? So let me see the step by step. Let me first clear it, and then let me give the podman image command first. Okay, we can see that this httpd 24 image, okay, with the tag latest, because we did not provide any colon and the tag, so by default is getting the latest image from for the httpd 24. So okay, so this image is now has been stored in our repository, local repository. Now let me run the podman process command, ps command. So here we can see this image is running, okay, in the container. This is our container ID in this container, and then created 47 seconds ago, and status is up. Okay, so this is up and running, and the port forwarding is from our local machine 8080 port to the container port of 8080. Okay, TCP. And it's by default, because we did not provide any name, so by default it assign a arbitrary name to our container. Okay, so now we know that our container is running. How we can check our container, because this is the web server, so we should be able to see the result of this web server by in our browser, right? So let me give here localhost 8080. Okay, because our local machine's 8080 port is now forwarded to the container port of 8080. Okay, so here we have we also receive the result of hello world from the nginx. Okay, so this is returned from the container. Okay, our local machine is forwarding this request to the container, and container is returning this result to us. This is how the container is running. Okay, now let me see how the other commands. Okay, how we can stop the container. So we know with the podman ps command that this is our container id. If we want to stop the container, we can give command podman stop. Okay, and either we can give the container id this, or we can give the container name this. Okay, so let me give the container name and let me stop it. Okay, so the container is stopped now, and if we go here and we'll refresh this page, now it is reload, right? So this is not returning. You can see this process is going on, and sometime back it will return a error that this page is not found. Okay, unable to connect. So because the server has been stopped now. The other command is like if we remove the container. Okay, now we have stopped the container, and if we will again give the command podman ps, it will return us nothing. Okay, because no current container is running there. Okay, so we have to give command ps podman ps with the hyphen a attribute, means with all. Okay, so now all container it will return. So it has returned there these containers. Now what we can do, we need to remove this container. If we want to remove this container, we will give command podman rm, and then we have to provide the container id. Okay, there are two ways. If multiple containers we need to remove, then we need not to give the whole id there. Like if we like I can give this whole id, or the identifier of the id only, right? Because this id is starting with the 5, and no other container id starting with the 5, so I can give the 5 here also. Okay, so this is the identifier. 5 is the identifier of this container id. Likewise, I can provide the 0. Okay, so either way you can provide, either you can provide the full container id, you can provide the container name, or the identifier only. Okay, so if I will give this, then it will remove all these three container, this container as well as the container which is starting with the 5, and the container which is starting with the 0. Okay, so let me do it, and it's returned the same. It means these containers has been removed. And if I run the command again ps-a, then it's returning nothing, means we have removed, right? Same way we are having podman images. So these all images we are having in our machine. If I wanted to remove these images also, then the command podman rmi, I have to give rmi, means remove images. Okay, and the same way like we did the image id, we can provide, either we can provide the whole image id here. Okay, the whole image id, or we can provide the identifier like ba. Okay, let me provide the ba. Okay, so it will identify that this is the id start, ba id is that which is starting with the ba. Okay, so let me provide it, and the both images has been removed. If I will run the podman image again, so nothing is returned here. Okay, so this is what how the container is running. You can go there and can practice well of the lab 1. I am moving to the lab 2 now, the container networking. Okay, and let me first give you some brief of this networking. Okay, so the container networking. Okay, so once there might be the applications which might be running in the number of containers, like we are talking about the microservice environment, in which there might be the hundred of microservices which are communicating with each other. Okay, so these communications and communications require a network also. Okay, so here you can see example here. Here is suppose I am running a application in the three containers. One container is running the UI. Okay, user interface of the application, and second part of the application is running in another container which is having the all backend APIs here we have written, and third container is running with the database. Okay, so I want the security here, so I want that only the API applications which is running a separate container only should be able to connect with the database. Okay, so what I will do here, I will create a API network here, and I will provision this connections between the API container and the database. Okay, and then I will create another container UI network, and here I will connect these two containers, UI container and the API containers. Okay, this is how we can apply the security and make sure that the our applications would connect with each other. Okay, multi-container applications. So this is the concept of the multi-container. So now we are uh, doing some deep dive here. Okay, so to understand the multi-container. Okay, so let me understand this whole concept via the hands-on. Okay, by using another lab. So what we will do here, okay, so we will understand this all container network thing. We will understand how we can create the container network. Okay, how we will connect our applications into this container network. Okay, so by default Podman provide a network with the name of Podman. Okay, if you will give this command, let me first clear it. If you will give command podman network inspect podman. Okay, so this podman is the default network. Okay, provided by the podman itself. Okay, so you can see the DNS enabled is false. Okay, so we will not do many things here in the default network. Okay, let me, and this is the beyond of scope of the exam 188 also. Okay, so we will not go into the deep as of now. Let me create our own network here. Okay, for the lab purpose and to show that how this communications of multi container application will happen. Okay, so let me create a container first. Okay, and I will explain the command you. Podman is the keyword first, and then we are creating the network. Okay, so network, okay, and then create means we are creating the network, and network name would be the cities. Okay, so let me create here. So it is saying that cities network is already created. Okay, so let me go into the help section, and then I will show the command which is there. Okay, for related to the network. Okay, so the create is one. Okay, and the remove is one, right? So we can remove the network also. Let me go ahead and remove the already created cities network first. Okay, so for it we will give the network and rm and cities. Okay, so this network has been removed now, and now let me again create the network with the name of cities. Okay, so cities network has been created now. Let me clear it, and let me inspect this network. Okay, inspect command is to go there and inspect the things. Okay, so here you can see the DNS enabled is true, the cities network is created, the other things you can see here. Okay, okay, so what we will do in this creating network lab, okay, the exercise. So here we are having two applications, or you can say the two microservices which is written in the Go language. One is the times app application, and another is the cities applications. Okay, so the cities application will connect to the times application, and it will return the time of the city. Okay, because okay, so I have feed some cities there in the cities applications, and then cities application will connect to the time applications. Okay, so what we will do here, like we understand this thing in these examples. Okay, so we will create a cities network here, and then we will connect these applications, time application and cities application into a single network. Okay, so for it we have created this cities network. Now let me run the time application. Let me check how this time application will work, and we will assign, we will run this time application into the cities network. Okay, so let me go there, and let me run this command. Okay, so what it will do here, it will create a container. Run means it will create a container, and the container name would be times app. And then we are assigning, right? We have already created the cities network, so we are assigning the cities network to this applications. Then we are doing the port forwarding 80. My application, this application is running on 8080 port. Okay, this Go application. So we are forwarding our local port 8080 to the container port 8080, and hyphen d means we will run this application into the background in the daemon thread. And then I am getting this image from this repository. Okay, so this is my repository. Okay, and docker and ts rana 1, and then the image name is podman info times. Okay, and its version or tag is v 0.1. So let me do this. It will trying to connect to the Docker registry and trying to get the image. So this is happening now. It is getting the image from the Docker registry. Let's wait for a moment. And now it is trying to run. Okay, so now the application is running there. If we will give command Podman PS, we can see that yes, our container, okay, is running this image, and this container is up and running for 7 seconds now. Okay, and the created 8 seconds ago, port forwarding and other thing you can see, and the name we have provided this time, no default name we have provided is the times app. Okay, now let me go ahead and inspect our application. Okay, with the command podman inspect, you can inspect the things. Okay, so here we are trying to inspect the times app container. Okay, and then it will try to find this keyword from the inspect. Okay, so it has returned a ip address. Okay, if I will give the inspect only, okay, without any hyphen f, then it will return the whole JSON document of my container. Okay, like here you can see this is returning the whole JSON object. So this is the lot of information, right? So if I want to get a particular information with whole this information, this is the whole container information it has returned. Okay, so if I want to get only the particular information, then I can give the hyphen f. Okay, that this value only I wanted to get. So here this is I am wanted to get the internal IP address of the container in which my application is running. Okay, so this has returned the container IP, internal IP to me. Now I can access my application using this IP also. Okay, now let me try to do one thing here, interesting thing. Okay, let me first copy it and then run it, then I will explain to you. Let me first clear the things, or uh, let me run here itself. Okay, so what we will trying to do here, okay, we are again will create a container here, and hyphen rm means once container is done, it will also remove all the resources of the containers once the container is exit my status. Okay, then we are again giving this container in the cities network, adding this container in the cities network, and then we are trying to get the base image of the universal, right, Red Hat Linux universal base image, and then we are providing the curl command here, okay, to the container of the Red Hat, and we want that it should print, right, it should get the times of Bangkok. BKK is the code of the Bangkok. Okay, so here I need to replace the IP address with the IP address which we just get from this command. Let me copy this and then paste here and run this. So what it is first trying to do is it is trying to getting this universal base image of the tag 8.5 first, and then it will run the container. Okay, so it's done now, and you can see here um, it has returned the Bangkok time here also. Okay, so it is running fine, right? But every time we need not to. I just provided you these steps so that you can get the internal IP of the address of the container. Okay, but in general way you need not to get, because this is the dynamic IP address. Okay, so we will use the DNS, not the IP address, to connect with the application. For an example, I just shown it to you, right? So how the DNS will work here, let me understand in this next command. Okay, so let me first clear this screen, and if I give the next command. So what we are going to do here, we are again will run the container again, and rm mean hyphen hyphen rm means it will remove all the resources, everything is storage, memories, once the container is completed. Then we are assigning the cities network. We are getting the same again, the universal base image of Red Hat, and then the curl command we are passing here, and this time instead of IP address we are providing the container name. Okay, so by default how it is working, once we are running a application inside a container and inside a network, and okay, so what it will do, by default it will take the container name, right? Because once we run this application times app, right, we give the name of container as times app in the cities network. Okay, so it will register the container name as the DNS of the application. Okay, so instead of IP address we can give the times app here as the DNS, and same again colon 8080 in which the application is running, the port number, and again we are trying to get the time of the Bangkok city. Okay, so if I will run here, you can see it has returned the time of the Bangkok city. Okay, so let me copy the next command, and then I will explain how this microservice communication will happen between these two applications. So what we are doing here now, we are running the application, and this time application would be the city app. Okay, so we have given the name of this container as the city app. Network is the same as cities, and this application is running on the 8090 port and will run in the background. And here I am providing an environment variable also to the container, and this is the key of the environment variable, and this is the value, right? In this value I have provided the URL of my times app. Okay, so that this communication could happen, this microservice communication from cities app to the times app could happen. Okay, so this I have provided, and then my image name. Okay, so this is my image which is the Podman info cities, okay, in the Docker Hub. So what it will do, it will get this image first, okay, Podman info cities with the version 0.1, and then it will execute. So let me run this. It is trying to get the image from the Docker, and then it is executing. Okay, now this is running. Okay, now how we can access it? To access it, let me go to our URL, our local machine URL here. Okay, with the local host 8090, because our application is running on the 8090, this city application. Okay, and then let me get the value of the some cities. Okay, let me first execute this one. Okay, it's written a JSON document. Okay, mandate, and we can see the time of the mandate, the population, and other detail about the city, like in the Spain mandate country with this population, and this is the current time. Okay, likewise we can run the another example. Okay, this is the for San Diego. Okay, and the country is United States of America, population is this much, and this is the current time, right? So this current time is, it is getting from the times app. Okay. Okay, now let me do the further deep dive into the containers, and let me see how we can access the containers, right? So what containers we have created, how we can access them. So let me first execute this command. Okay, this is the Nginx web server. Okay, so let me execute this. Let me first clear it. And now execute this command. So what it will do, it will again same, it will create a container. Okay, and container name would be nginx, and it will, then it will run this container into this port. Okay, now it will return a say error. Okay, why? Because our application is already running on 8080 port, right? So our um, local machine 8080 port is already busy. Okay, so what we have to do first, we have to first remove the previous container first. Okay, so let me go to the Podman, and let me see the ps command, right? So here you can see our local 8080 port is already busy, right? So what we have to do, we have to remove all this container first, and then we can proceed, right, by using this port. So with the command podman stop, and then we can give identifier C and 5. It will stop both the container. Okay, and then let me give command ps-a. Okay, so here we can see two containers are in exit status. Let me remove them as well. First we have stopped them, now let me remove them. It's done. Let me clear it, and let me run this first command of the lab 3. So here what we are trying to do, we will run a container with the name of nginx in the background, and then we are doing the port forwarding of our local machine port 8080 to the container port 8080. Then we will get this image from my Docker hub, and image name would be the podman nginx hello world. And you can see I am not providing any colon here further, and the name of the text. So what it will do, it will get the latest image from the image registry. Okay, so let me do it. So first it will trying to getting the image, pull the image from the my Docker hub. Okay, it will take a while, and once image will be there in the local repository, then it will create the container. Okay, so our container is created and running. Let me see with the podman ps command. Okay, so our container is up and running, and here is the port forwarding. Okay, so container is up and running, but it will provide, deliberately I inserted some issue here. Okay, so that we can go ahead and can do the some troubleshooting inside this container. Okay, to fix the problem. If I will try to access this container, okay, with the uh, 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 by the browser accessing this on 8080 port. Okay, let me refresh it. Okay, so it is giving the error as 404 not found. Okay, so deliberately this nginx container is not working because some issue is here. Now what we have to do, we have to go inside the container, and we'll have to identify the problem. Okay, and then we will fix the problem, and then our application should be run there. Okay, so what we need to do first, okay, let me first get the error log, okay, of the nginx server. Okay, so what we are trying to do here, let me first copy it, then I will explain here. Okay, to troubleshoot the error, we need the log file, right? Error log file. So before it, let me first move to my directory here, so that we can copy correctly. Okay, so this directory is empty as of now. So let me run this command. So what we are trying to do here, podman cp means copy. So uh, copy this file, okay, this file from the container into my local machine, okay, with this name error.log, okay. So inside the container, it will container name in nginx, okay. So it will go to the nginx server inside the this path var log nginx, and it will get the error.log file, copy it, and then it will place this file into my current directory with the name error log, okay. So let me run this. Okay, so its copy is done. If I do the ls now, I can see the error log is there. Okay, now let me examine this error.log file to troubleshoot the is problem. Okay, so here because I am in the Windows machine, I can give the notepad command. If you are in Linux, you can give the gedit command, vim command, or vi command to see the error log. Okay, so error log, it will open the notepad. Okay, and if I examine here, here is the error. What it is trying to say that user share nginx this html file, right? So once we are trying to run the browser, it is trying to find the index.html file, but in this file is not found. Okay, so this is the main issue by which our application is not running and it is returning 404. Okay, so let me do some more troubleshooting here. Okay, let me clear it and let me do some more troubleshooting. Okay, now what we are trying to do here, we in the podman, we will execute exec command. Okay, so we will execute some command in the nginx container. Okay, so our container name is nginx. We will execute the ls command in the nginx server. Okay, and ls means the listing of this directory. Okay, let me do it. So what it is saying that this directory is not there. Okay, so what so far what we have troubleshooted, we try, we see that it is trying to get some index file, that index file was not there. Then what path it specified, we check this path via the ls command inside the container, and it is saying that this directory is already not there. Okay, now what we have to do, let we go inside the container and let we examine more that why this path is not there, and if this path is not there, then we might have to make some change into the configuration. Okay, so for it, okay, before going inside, let me first copy the nginx configuration, that what values is there in the nginx conf file. Okay, so what we are to do here, we will copy the nginx conf file from this path from the nginx container into our local machine with this name nginx conf. Okay, let me do it. Copy is done. Let me see the ls command. Now the file nginx conf is also copied in our local machine, and let me examine it with the notepad nginx conf. Okay, so here if we examine this file in detail, okay, then here we can see it is trying to get right this the root here we have specified user share nginx html public, but we have already see with the ls command that this root is not there. Okay, so this means here is some problem here, the path we have specified here is wrong, right? This path is not existing into the server. So that's why let me go inside the server now to fix this issue, right? How we can go inside the server. Okay, so we will give command podman exec. Okay, means we are now trying to access the nginx Nginx container, okay, in the interactive mode. IT means in interactive mode, and we will go into the bash shell. Let me do it. Now we are inside the container. Okay, now inside the container, let me see the value of this file, okay, with the vim command. So we are in the vim command inside the container. Here are the values, okay. So this path is actually wrong there, okay. So if I give quit, I am here, and let me try to go into this path. Cd user share nginx html, right? And if I give ls here, so public directory is not there, but other files, our index file is already present there in the html, right? So this path we have to give into the nginx conf file, right? So now let me go into the vim command, okay, and then try to update this file here, okay. So we have to go into the root section, and then so here it is saying us that it is the read only file. We cannot make update here. And if we will try to make update here, and then if we will try to save it, okay, with the wq command, it is saying this is the read only option, means the id via which we are trying to access this file and this server is not the privileged id, okay. So what we have to do, we have to quit it, and let me exit from here and come back to our windows machine. Let me give the um, Podman ps command, and let me stop this container, um, and also remove this container, and let me again run this container with the privileged id, okay. So this is again for your learning, okay. You must run the application with the privileged id if you need to do something there inside the container. How you can log in with the privileged id? Let me again copy this command here and then run this command again, and now here I will use the one more parameter here, one more attribute here is the -u, and I will log in, run this application as the root user, okay. So this now I have added as the -u root, okay. Now let me run this again. Our application is running. Now let me go inside the application again, okay. And now if I will check who am I, it is giving that I am running as the root user, okay. Now let me go inside the vim nginx conf and make the update, okay. So here let me go to the root and let give the correct path here. Correct path is still html, so we need to remove this and then save it. That's all, and then exit from the container. We have exit now. Let me again reload the nginx server so that it could take the latest change of the nginx conf directory, okay. So what we are doing, we are executing the nginx -s reload command in the nginx container. This is the container name, okay, and this is the command name. So let me do it. It will again load the nginx conf. It is done. Now let me try refreshing this page. This time this application should run good, right? So hello world from the nginx. So our application is running well, right? So via these three labs, we understood, right? First, how we can create the containers, In the second, how we can communicate the containers, right? Multi container applications like microservices. I shown you two microservices are connecting in the network. Then in the third lab, we see how we can go inside the container, and if any issues is coming in the container, any application issues. Just show you with the simple one of the web servers, right? Nginx web server. Your application could be any Python application, Java application, Spring Boot application. If it is giving some error, you can go inside the container and can do the troubleshooting. You can make the changes in the container itself. Okay, so this is all about this tutorial. I hope you will like it. Thanks very much for watching it.